Welcome to another episode of Talk Tech with Data Dave, and today we're doing an expert episode. Talk Tech with Data Dave is proudly brought to you by D3 Clarity, your partner in AI, data, and cloud innovation. At D3 Clarity, we offer industry-leading solutions designed to transform your business and drive lasting success. From tailored consulting services to cutting-edge technology strategies, we're here to take your operations to the next level. Ready to unlock your tech potential? Learn more at d3clarity.com. Before we get started, I'd love to remind our listeners, you can always reach out to us with a question for Data Dave by emailing us at talktech@d3clarity.com. You can also send us a question right on the D3 Clarity website, or you can connect with the Data Dave or I on LinkedIn and send us a question right there on LinkedIn. We love to answer listener questions on the podcast. So please send us some questions. We will be happy to answer them on the podcast, give you a shout out, and maybe even have you send in your questions so you can be featured on the podcast. But like I said at the beginning, we're doing an expert episode. Dave, today we have with us Erik Lee, which probably a lot of you remember from a Data Dave Dives Deeper that we did earlier this year. Dave, Erik, how are you guys today?
Excellent, very well.
I'm doing
Glad to
great,
be here.
thank you. Yeah.
Hopefully
Super
you
happy
guys
to be
remember.
back.
Yeah, hopefully you guys remember Erik from his Data Dave Dives Deeper episode earlier this year where we talked a lot about taxonomy. I think we ended somewhere around talking about shoes, and that's how I kind of understood taxonomy. But the place we landed was with Dave. You said, "Hey, I wanted to talk about ontology, and I wanted to talk about knowledge graphs, but we didn't get to talk about them today." And I was like, "Well, that's going to have to be a question for another podcast." So
Right.
we brought back Erik to join us for another podcast where hopefully today we can answer the question, what is ontology? We said it before, and I will say it again. That's ontology with a T, not oncology with a C, as in not oncology as in cancer studying, but ontology as in whatever the gentlemen are about to explain to me that probably has something to do with taxonomy. So if you didn't get a chance to listen to that first episode, go back and listen to it. It's episode 42. Otherwise, I'm going to hand it over to you guys. Please help me. What is ontology?
Yeah, so I'm going to hand it over to Erik first because ontology is often, people often use it somewhat synonymously with taxonomy and somewhat not. And it actually has two meanings according to the dictionary. So a branch of philosophy that deals with the nature of existence is the first definition. Which we're not necessarily going to talk about because that gets quite involved and so on. The second definition is a list of concepts and categories in a subject area shows the relationship between them, which I think is more relevant to what we're going to talk about. We're not going to go into Aristotle and Descartes and various other deep philosophical discussions on the, I think, therefore I am, which is the other ontological study. So let's, I'm going to hand that to Erik so Erik, as a taxonomist, not a taxidermist, but a taxonomist, what is an ontology? What do you consider an ontology, and see whether we can separate some of this confusion that I know exists in the world.
Cool, thank you very much. So it's interesting that definition that you put up said it was a list, because really it's not so much a list as it is kind of a whole structure. It's a semantic structure. It's based on the meaning. And yes, it's the kind of high level definition is it's a concept model of a domain of knowledge. So when you think about it, it's the things that are in a domain of knowledge, let's say like medicine. So it's the things that are in that domain and the relationships between them made explicit by this modeling. So in medicine, you have things like patients and treatments and conditions and diseases. And they'll have relations like patients can exhibit symptoms, patients can have a condition, symptoms are demonstrated in this way. Um, Conditions have a particular set of symptoms. So it's a way to kind of organize and just model that whole domain in a way that makes it easier to kind of understand and see kind of what those connections are and how the different kind of concepts relate to each other in a way that can also be made machine readable.
A list of concepts and categories in a subject area that shows the relationship between them. The key part of that is the relationship between them, is what I got from what you were saying, right? So we've got a list of things like symptoms, like diseases, like physicians, like body parts, anatomy, right? All these things can be categorized in the domain of medicine, but there isn't as strict a relationship as there is in a taxonomy, correct? It's more a disease can have any number of symptoms, and more also many symptoms can be related with many diseases. So we've got many to many type relationships, where in taxonomical terms it's usually more rigidly a hierarchy.
Right.
You had
Yeah.
mentioned it was more like a parent-child in taxonomy.
That's
This
right.
sounds more like
And
Like a
yeah,
network,
so like
like
spider.
a
I don't know what.
taxonomy usually ends up looking like a tree, and you can have some like related term or preferred use, but yeah, it really the strength of the ontology is those you can really develop like what these relationships are. So as opposed to a tree, like I think you were thinking, in an ontology, like if you have it in a graphical format, it looks like a web, basically.
Yeah.
You have these the things are like usually in circles or ovals or whatever and connected by the lines, and the lines are those relationships. And it comes out of a field of mathematics called graph theory, where basically it has these things called vertices connected by what's called edges, and it's related to like topology, and it has several different uses in mathematics where you can kind of calculate these relationships.
I liked your like medical example there, but I need you to like dumb it down even further for me.
Think of
Um,
cities and roads.
okay,
Think of
okay.
cities and roads on a
Mm-hmm.
map, and where your thing is a city and your edge, your relationship between those cities is the road. So the city of Chicago is connected to, I don't know, um, Detroit by an interstate,
Yeah.
right?
So
So
yeah,
Chicago is a thing, Detroit is a thing, and they're connected, related by the road.
yeah, by like uses Highway 111 or
Right,
whatever.
exactly.
Hmm. Okay,
Or
okay.
even within a city, like going from your house to like City Hall. There's different roads. It has these different connections. So it's a many to many. Like my house connects to City Hall via, Main Street, via First Avenue, and
And if you think about it that way, then you can start to, if we relate that, you could start to say that a large thing is a city and a house is a small thing. The house is within the bounds of the city, but your house is also related to your parents' house because you're related to your parents, right? Does
Mhm.
that make sense? So you can build a map that is multifaceted, so to speak.
Yeah, this is actually a great example because it's one of the real strengths of an ontological structure is you can make new connections based off of that. So like in that medicine one, like let's say, you have a patient has a condition, and the condition has a part of the body it affects, and the condition also has a treatment that treats that condition. You've also created this thing where the treatment affects that part of the body that the condition affects, because
Mhm.
you have those relationships between the condition, the treatment, and that part of the body. So you can make kind of new connections based off of existing ones. So yeah, through those connections, you can say, oh, these things are connected in this path. So if I query along this path, I can get this new connection made. I can get information put together in a new way based on these connections.
You guys kind of just explained the difference between taxonomy and ontology to me a little bit with the tree versus web, but talk to me about it in applicable terms. When would you use ontology over taxonomy, or when would you apply them separately or together? Help me understand that from like a business use case.
Yeah, an enterprise or an organization, and we kind of touched on it a bit, can have like these multiple systems that are trying to communicate with each other across the entire enterprise. So having an ontology can connect all these things in a way where the they it's a shared language across the entire enterprise. So it really helps get past like data silos and information silos, and also provides this kind of shared understanding. So I know we gave the example of the customer talking about
Mhm.
ontology. So for instance, for talking about taxonomy, sorry. So in an ontology, you can say like a customer is a person. Customer has a name. Customer has a user ID. Customer has an address. Customer has a marketing profile, and all these ways that can connect. So if you're doing, for instance, analytics, you can pull, like I said, you can do this, what's called inference, pull these connections. So you can say, hey, and use it in a bunch of different ways. For instance, you could query, I want to know every customer that has hometown Chicago, and pull that whole list just based off that connection, and then connect it to each other. It's like, okay, these people are all in a particular area, depending on what's important and how you decide to model that information.
We talked about the taxonomy of shoes,
Mm-hmm.
right?
Okay.
And we got the taxonomy of shoes, where shoes are in a taxonomy of classification: women's shoes, men's shoes, green shoes, black shoes, various taxonomical discussion of shoes. Shirts are not in the taxonomy of shoes,
Right?
right? Makes sense?
Mm-hmm.
I can have
Yep.
another taxonomy of properties for shirts, right? We're all wearing blue shirts.
I noticed that earlier.
Just interesting. But that's a taxonomy of shirts,
Mhm.
right? Now, the fact that Alexis bought this shirt and this pair of shoes does not cause the shirts to be in the taxonomy of shoes, right? But it does mean there is a relationship that can infer a relationship between that shirt and that pair of shoes, because they are both owned by Alexis.
Mm-hmm.
Okay.
Okay.
So now I've got a linkage between that blue shirt and this red pair of shoes because Alexis owns them both.
Yep. And now if I'm a retailer and I have this thing, I can say Alexis has these shirts, Alexis has these shoes, and I could use the power of recommendations. Like if she likes those shoes, these shoes have similar qualities, so she might enjoy these shoes.
Right.
Or, we have like some sort of a matching engine, like that will say like, hey, if you like these shoes, here are certain matching, dresses to go with it, for
So
instance.
we've inferred a connection that is not part of the taxonomy.
And back to Eric's example, I'm learning here. Tell me if I'm wrong. back to Eric's example, if we are using the some sort of engine that says if she bought these shoes, she's probably going to like these similar shoes. Those similar shoes are probably being picked because they have similar metadata attached to
That's
them.
right. Correct.
Mhm.
Yes.
Yes, exactly.
I
Yep.
got it. I understand it.
Exactly. And then you can say things like, because Alexis picked those shoes, somebody like Alexis might want this shirt that Alexis liked because Alexis liked these shoes.
And how do we know what Alexis is like? Because we've got this metadata that can be this taxon that comes from a taxonomy that says, oh, she's outdoorsy, or she is business casual, or these ways of describing you as a customer that can also describe other customers. So an engine can say, oh, this metadata this has the same metadata, these people, so we can start pulling, putting that together for the recommendations.
It's not strict, but you can pull this. You could say, from the evidence presented in us, that people on Talk Tech with Data Dave wear blue shirts.
Mm-hmm.
Therefore, future guests on Talk Tech with Data Dave should also wear blue shirts. Therefore, we should sell blue shirts to people who are going to be on Talk Tech with Data Dave. That's assuming that Talk Tech with Data Dave has any power in retail.
Mm-hmm.
But which I doubt.
Which we don't. We have one shirt design and it's actually black, but that's a different story altogether.
But you see how the connection is made, and then you can start to infer knowledge from the connections.
That is the perfect segue to the last kind of question I want to ask. Okay, you just said we're inferring knowledge from it. And then Eric, earlier, you said that this idea was taken from a mathematic concept of data graphs, I think you said, which
Graph theory.
Graph
graph
theory.
theory, right. And then Dave, back on the other episode, you had mentioned that you wanted to talk about knowledge graphs. And I was like, what the heck is a knowledge graph? Because like to me, I think about It's Always Sunny in Philadelphia, where Charlie Day is trying to connect all of the little things in the mailroom. If you've never seen it, it's very funny. There's lots of memes about it. That's my knowledge graph. I move on. Please help me understand what that means.
So really, what a knowledge graph is at its most basic is it's applied ontology. It is an organization or company has taken an ontological structure and put their data and their information and what they want to model into it. And that way it connects these concepts to concrete items or systems or units or things within the organization. So we were talking about like, oh, an ontology of the customer. So a knowledge graph would have like, all right, the individuals within the class of customers. So a class is a grouping of individuals that all has common attributes basically. But each individual like has their own value for user ID and stuff. So it takes those, there's a list of individuals with the user IDs, and it instantiates that so it's actually used like, okay, we have an ontological structure. Now we put like our data in it so we can use it for the things we want to use it for. And you probably hear it a lot too, used in relation to like large language models or AI, because a lot of these models, they work on statistics, like how tightly related are these words that are being used in the query, for instance. What a knowledge graph does is it makes these relationships explicit. It says these two are connected in this way. So it adds a lot of statistical weighting to the stuff that's modeled in the knowledge graph, which means the response that you're going to get is a lot more likely to be reliable and based on your information because you're specifically giving it relationships to weight to work on.
So think of it, one example would be, think of it as a knowledge graph in a diagnostic framework, right? So I've got a problem and I'm calling customer support about my car, right? there's a whole bunch of knowledge that is factual, that can be related to each other. If I've got a flat tire, right? Part is tire, issue is flat, symptom is it makes a loud noise and wobbles a bit when I go around a corner, right? There's symptoms, there's issue, and there's a part. Those three pieces are knowledge. That's explicit connections that an expert would have that said, if it does this, it's highly likely your tire is flat and the part that needs to be replaced is the tire. Right? That is knowledge. That is things that an expert would know. You can also plot that on a graph. So you can say, my symptom is this, my failure is this, and my part is this. Now expand that to say, well, my part is connected to my wheel, connected to my axle, connected to my engine. You can build up this graph, this structure that starts to describe a whole load of symptoms, failure, and parts on my car, right? What your customer support rep can now do is walk that knowledge graph to say, what symptom did you experience? If you experience that symptom, then it's probably this failure linked to this part. Maybe you should do this. That can get very, very complex, right? And so that's the concept of a knowledge graph, a graph that describes, in that scenario, all the failure states, all the symptoms, and all the parts of my car, so that now as a user, I can walk that graph to assist in diagnosing, okay, I've replaced the tire, it still wobbles around the corner. Okay, maybe it's the wheel bearing. Okay, maybe it's the this, maybe it's the that, whatever it might be. And you can continue to walk this graph and that sort of thing. And often in AI, and think of an AI chatbot, right? You can automate with this knowledge that was extracted from an expert. You can now automatically walk this graph to say, okay, what symptom did you have? Have you checked your tire pressure? Right? That's before I need to get to and go to a mechanic. That's just mechanical walking my knowledge graph, but I've got that AI type smart that is now mimicking the expert in the conversation.
Yep. And if you're an enterprise, like, okay, yeah, you sell car parts or something, if you have a connection between like your products and this into the graph, you can say, oh, the problem, like, oh, you have a flat tire. Would you be interested in purchasing a tire? And the connection, and there's also a connection between like this model of car, has, uses this size of tire, like it'll, these ones will fit your car. Here you go. Are you interested? And do stuff like that too.
So these three things on ontology, taxonomy, and knowledge graphs, it sounds like they are very much used together very, very regularly. And just like when we were talking about taxonomy, it sounds like these are things that are being used in our everyday lives, although we maybe don't realize they're being used in our everyday lives.
Absolutely.
Yeah.
Absolutely.
Yeah.
These are mathematical terms and structured terms for things that people use all the time. Categorization.
Right.
Yeah.
Right?
Yeah.
Relationships. Related information. All this is what we're talking about, is just these are the precise terms for naming some of these areas of study.
Yeah. Even like your morning routine, like, okay, it is morning, these are activities that happen in the morning. So I need to go to the bathroom because that is where I brush my teeth, and I brush my teeth before eating, and which is an activity that happens in the dining room, etc. So it's making that kind of just implicit knowledge, like, okay, that I do this, and explicit and able to be calculated, acted upon, and machine readable.
And mathematically modeled.
Yes. Okay. I like that. I think those are wonderful definitions of those two items. I now have three more items that I'm actually understanding a little bit more, which I really appreciate. Erik, thank you so much for joining us again on Talk Tech with Data Dave. This has been wonderful. I'm so happy that I'm actually understanding things a little bit more now. That when I have breakthroughs like that on these episodes, I'm like, yes, that's what this is all about. Yes.
Yes. Excellent.
Dave, as always,
Yeah.
it's been wonderful. Thank you so
As
much
always.
for being here today. Listeners out there, as always, I will say it one more time, please send us questions. You can reach out to us via email at talktech@d3clarity.com. You can hop on the D3 Clarity website, or you can reach out to Dave or myself on the LinkedIn and send us questions right there. Erik, again, thank you so much for being with us today. Dave, thanks again for chatting.
Thank
Been
you.
a real
Thank
pleasure.
you, Alexis.
Thank you.
Always a pleasure. Thank you, everybody.
If you have a question for Data Dave, reach out to us at talktech@d3clarity.com. We'll be happy to answer your question in the podcast. Thanks. Talk Tech with Data Dave is proudly brought to you by D3 Clarity, your partner in AI, data, and cloud innovation. At D3 Clarity, we offer industry-leading solutions designed to transform your business and drive lasting success. From tailored consulting services to cutting-edge technology strategies, we're here to take your operations to the next level. Ready to unlock your tech potential? Learn more at d3clarity.com.